Hello guys, so welcome to biology video lectures with Akerele Oladimiji Philip. It's my wonderful pleasure to have you with me on the lecture. So we'll move on to the next topic on the series on organization, and that is heart rate, like heart rate. The rate at which the heart beats, like how fast, how slow it is, as the case may be. So basically, the natural resting state of the heart is controlled by a group of muscles. Now, the point is this, of course, we're trying to explain how some structures help to control the rate at which the heart beats. That's what we're trying to do right now. So he says here that the structures that controls the heartbeat is called, or they are collectively called the pacemaker, or sometimes we call them the electrical system of the heart, so to say. So here it says the natural resting state is controlled by a group of cells located in the right atrium of the heart. Not just the resting state, any kind of rate, I mean, whether it's fast or slow, so to say. Now, the role of the pacemaker is to coordinate the contraction of the muscles of the heart. Therefore, it regulates the heart rate. So if the pacemaker discharges impulse very fast, it means that the rate at which the heart contracts and relaxes is going to be faster. And if it discharges the impulses quite slowly, it's going to be slower. So let's check this out. So this is the electrical impulse of the heart. Now, for the sake of the curriculum, I'm not going to go too deep, really. This is not totally an A-level video, but I'm going to once in a while say some few stuffs for A-levels, but it is majorly not for that, but everybody will benefit, that I can assure you. So basically, this here is the SA node, which is called sinoatrial node. Then this is the AV node, the bundle of His, the Purkinje fiber. Those ones I mentioned are for A-levels. But for the sake of O-level, all you need to know is SA node, which means sinoatrial node. What does that do? That's the headquarter of the impulses. So it gives from, if you look closely, you notice that it starts from the SA node, go to AV node, then it goes to the bundle of His, then the Purkinje fiber, like that. So, and that explains why these two contract first. Why? Because the impulse gets to the left atrium together, then afterwards it goes to the ventricles. So because the initiation of the electrical stimulation comes from the right atrium to the left atrium, the two of them contract first, then sends the impulse to the ventricles, then the ventricle contract. You can see that right there, so to say. All right, so basically up to a point, the faster the rate, now it's up to a point, it means to an extent, the faster the heart contract, the more quickly oxygenated blood can be delivered to the heart, to the body. I mean to say, let me explain that real quick. It tells you that during fight or flight, when adrenaline is at work, the rate at which people's hearts contract increases. Why? Because the more the heart contracts, the more blood is pumped faster, it gets to the lungs, picks up oxygen, goes back to the tissue. The aim is to be able to help meet the need of the body during fight or flight or agitation. When a person is at rest, the oxygen demand of the cells is relatively low. So a low heart rate is maintained. So when we are at rest, like as I am right now, the heart is contracting about 72 beats per minute. If I'm asleep, the heartbeat is about maybe 70, 68, thereabout. However, if somebody is asleep and you're having serious nightmare, you can still have a heart rate that is quite high, so to say. Now, on the other hand, when a person is exercising, the oxygen demand of the muscle cells increases, so there's a need for an increase in what? In heart rate. So the pacemaker at that point sends out an electrical impulse which spreads around the muscle of the heart, causing them to contract. But this time around is going to be sending them out quite faster, thereby making the heart rate to be increased. This is very, very important. So here I'm trying to show you Not exactly, but at least to an extent. This is the heart of someone at rest. Like it's quite slow. Yeah, quite slow. Then when somebody is exercising. Now let me say at this point, aside when you're at rest or at or exercising or scared or because let me say this also. Your heartbeat can also increase. Your heart rate can increase even without you exercising. For example, if you're nervous, for example, you are just told, okay, in the next 5 minutes, you're going to be addressing a nation. What? That naturally increases your heartbeat even when you're not exercising, because that thought of what would I say, how will I say it, is some sort of stress upon you. So, and your cells are going to work more. For that reason, there's a need for your heart to pump more blood. Now, aside whether at rest or exercising, your heart rate also varies with the gender. It's quite faster in females because heart of females are generally smaller. It's quite faster in children. So there are some other factors that can affect heart rate, not just whether you're at rest or exercising. So sometimes the pacemaker of the heart stops functioning properly. This is sad. This can cause an irregular heartbeat. When you see my video on physiology, medicine, you're going to see me talk about this in details. Medical students will understand that better, really. There's something we call arrhythmia, heart murmur, all sorts of things, irregular heartbeat. Yeah, that's a topic for medical students or anybody that wants to learn about A-levels in medicine or biology. So basically, it says here, artificial pacemaker are now needed. So when the pacemaker is not working properly, what's a pacemaker? SA node, AV node I showed you. So you now need an artificial pacemaker to correct the irregularities of the heart rate. Why is there irregularities in heart rate? Because something went wrong with the pacemaker. So the device is implanted just beneath the skin with a wire that delivers an electrical current to the heart to help correct that, so to say. And this again, to double check, is, you can see, sorry, that's too much. That's the SA node. This is, you can see, synoatrial nodes, AV nodes, bundle of His, and all of those things. Good. That's the normal functioning one, so to say. Don't forget where it is found. You can be asked, where is the SA node found? It is found at the right atrium. Those whole parts is the right atrium there, so to say. Then don't forget the fact that all of these put together are called the pacemaker, really, like, but this is like the major one, like the headquarter of the whole thing, so to say. So now talking about when there's an issue. So this is the one I'm talking about right now. This is the artificial pacemaker. It's some sort of battery that discharges impulse intermittently to correct. You can see the way it works here. Good. That is it. It is delivering regular signals. So it could be put, I don't want to use, I know when I was taking some of my students in class, I showed the real picture of someone that has this, but I didn't have that here actually. But the point is, this is being put underneath the like subcutaneous. That means like the flesh is opened by a professional, then it is kept there underneath the heart, like underneath around the pectoralis here. Pectoralis is the muscle of the chest here, around here. So it's there like that. So it could work for years actually. However, but sometimes it could cause some sort of wound around there. That's as good as it is, but it has its disadvantages basically. But this is an artificial pacemaker of the heart.